Hey, I'm Z.
And I'm T.
So if your AC is acting up, a lot of people immediately say bad capacitor.
Sometimes they're right, but sometimes that won't fix a thing.
Now, before you swap parts, here is what a capacitor actually does and doesn't do.
Well, Z, what are these mysterious arcane objects?
So right here, I've got a couple of examples of two different capacitors. You might find these things inside of an inside unit or in an outdoor unit. They can be in a furnace or in an air handler. They're less common in newer air handlers, but there's still a lot of air handlers out there, indoor units that have capacitors just like this one right here. Now what these things do is they help to get a motor started, essentially. They store and release electrical energy. They release a lot of energy whenever the motor initially gets going, but if you've got a weak one, versus one that's at full strength, you're going to have issues maintaining the motor as time goes on. If you have a weak one, for example, you might have a motor that starts up a little slower but does eventually start, but at some point maybe the motor overheats. You've got one like this Mars capacitor here. It's a 7.5 microfarad. Typically whenever we see these things, we try to test for them and hope that they will test. This one is marked plus or minus 6%. Usually we say within 10%. So, if you've got a 10 microfarad capacitor and we test it and it tests at 90%, that's usually fine. This one, if it gets weak, your motor on the inside of unit becomes slow to start. It might not move as much air as it usually does. It may stop and the motor might not start at all. This is an example of the kind of capacitor you might see in an outdoor unit. So this one has 3 terminals, unlike this one. And so what you've got here is you've got one terminal for the compressor, one terminal for the fan, and another one that basically is common between the two. So it's kind of attached to both. None of that matters for anyone else's purposes. If we want to get into things that are more specific, we can. There's 2 things that we measure for whenever we test one of these things. You've got a 40, which is going to be for like the compressor, keeping the compressor going. And then you've got a 5 microfarad. That's going to be for the fan motor on top of the machine. Either of these things can fail independently of one another. There's been 1,000 times where I've tested a capacitor and it measured at 39.99 microfarads on the compressor circuit. But whenever I measured the fan motor circuit, it was totally open. The fan motor won't start, but the compressor does. Usually the machine will run for a minute and then it overheats and shuts down. A capacitor doesn't magically make a system cool better, but without one working properly, you're going to have issues getting a compressor started or getting a fan motor started.
So a capacitor won't just make a system cool better by itself?
No. It's certainly not a magic fix for making a system more efficient or making it blow colder or anything like that. But what it will do is help a motor or a compressor do its job effectively.
Now let's talk about what a bad capacitor actually does to a system.
You could have a fan motor that could be slow to start. Now, usually if you've got that, what you're gonna see is a capacitor that hasn't totally failed, but is it may be 75, 50% output. And so you might notice that the fan motor slowly comes on, makes sort of a wong, 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 wong sound before it actually, takes off. If one totally fails on an indoor unit, what you might see is just the motor not starting at all. If you're running the AC or if you're running the heat, maybe you hear the furnace kick on, but then it never starts blowing. Or if you're running the AC, maybe you hear the outdoor unit, come on right after the thermostat clicks, but no air comes out. In that case, you might get a situation where the AC freezes up and floods the place. So those are things that we try to avoid, and you can do that by just having someone check it every once in a while. In the case of an outdoor unit, it's a little bit more complicated. So this dude is responsible for starting the compressor as well as the fan motor on top. So let's say the fan motor circuit fails. So the compressor will still start. It'll pump refrigerant. The indoor unit comes on. You think it's working. But you notice hey, it's blowing, but it's just not blowing cold. Maybe you walk outside and the outdoor unit's making a crazy screeching sound or something to that effect. Or it could just be humming along and the fan motor's not moving. Those are all possibilities. Sometimes if they're not totally dead, you can do something like spin the fan motor with a stick and it'll slowly get up and start spinning. That's usually kind of a goofy, old school dead giveaway for a failing fan motor capacitor. Now, let's say the compressor circuit fails. In that case, the fan motor on top may continue to spin, but the compressor won't run, in which case everything will look like it's running, still blow air inside, but it just won't blow cold, similar to the fan motor didn't run. Eventually it'll quit blowing cold. Those are common failures. Every once in a while I'll see one of these things leak, or I'll see them just totally fail open altogether. And sometimes just nothing happens at the outdoor unit, or nothing happens at the indoor unit.
A bad capacitor can cause a lot of issues, but not every issue.
The bad capacitor is not going to cause the same kind of things that you'd see if you had refrigerant issues for that. It's also not going to fix airflow issues in one particular area of the home or something like that. It also won't fix duct problems. It won't replace a bad TXV. Having a weak capacitor is not going to make your house burn down, most likely, but get your system checked periodically just to make sure that you don't have one that's going to fail at a time you don't want it to. So just real quick, we're going to do like a bench test on one of these capacitors here. There's a couple different ways to test capacitors, but this is the most common, the quickest, the easiest. And 99% of the time, this is all you really need to do. We're going to start by switching on our multimeter here to this setting that's marked MFD. It's got a diode setting, resistance setting, a couple other things. But it's going to auto-select for microfarads whenever we go to put it on the capacitor. So we'll switch it on. It's currently not measuring anything. Now if I was to touch these together to check for continuity, it'll beep at me. It'll give me a resistance reading on the screen. It's important to note, we're not measuring resistance. This is not a resistor. You're not getting an ohm reading. What we're measuring is capacitance. It's something very different entirely. So just put our leads on a couple of points on this capacitor and let's see what kind of numbers come up on the screen. We're going to start and we're going to check the fan motor circuit, which is going to be between where it's labeled fan, the one with these two terminals, and the one labeled common with the 4 terminals here. .22 microfarads. Rated at 5. So 5.22, I'm sure that's within 6%. I'm going to check on the 40 side. We can do that as well. So we're just going to connect now between Herm and Common. We've got 40.8, 40.9 microfarads, which is spot on. I feel like it's worth mentioning these things just because I like this brand. We use these guys a lot of times on outdoor units. You can use them for a lot of different purposes to get you out of a jam. A zip tie, you've got the actual capacitor itself, and then some other hardware as well. You've got all your little jumper wires that you can use to make different connections and get whatever capacitance you need. And then it comes with a larger, longer screw that's a self-tapper that you can use to mount this guy in place. There's a little hole there in the zip tie. So let's say we wanted to replace a 25 microfarad capacitor. Well, that would be easy. You could just clip directly between 25 and common. But let's say you needed a 35. Well, in that case, you could just jumper from 25 here to the 10, just like so. Now, you attach between either of these points and common, and you'll measure 35. Now you could do this in any combination, summing these things up, as long as you add them together. You'll keep getting higher capacitance ratings. These things are super handy. Sometimes they're a little bit pricier than just one of the off-the-shelf regular capacitors like these. but they will sure get you out of a jam. They've also got these capacitor protection terminals, which you can use if you have a hard start, which you need in some cases. Totally different product here, also made by the same company. But yeah, if you have, say, a hard start being used in conjunction with a capacitor, you can hook one side of this to that capacitor protection terminal. And if this thing does happen to fail, it won't allow the system to start on this alone, which will keep your compressor from failing. So basically what I put together here was like a quick display to essentially show what a capacitor does in a system, and to try and simulate the effects of a weak capacitor. The actual blower fan itself, we're on this side, we've got the motor, its wires coming in. Thermostat, just like you would have on your wall inside. You can switch it to cool or heat, turn the fan on or off, turn the temperature up and down. Got a transformer. It's going to take in the power supply from either 208, 230 power supply or 120 volt power supply from inside the house. And it's going to step it down to 24 volts to power the thermostat and the switching functions inside of the machine. This is a relay. It's literally just the thing that turns the fan on and off. Now, for our purposes today, you can pretty much ignore this and this. We'll just focus on this capacitor here and the thermostat. Thermostat's just going to turn it on and off. And the capacitor will switch over to various strengths, and we'll measure the amp draw each time we switch it on so you can see what the effects are. Now, it's important to note that the manufacturer states they want you to use a 7.5 microfarad capacitor for this motor. So what we're going to do is we're going to show the motor running at 7.5 microfarads, because we've got this 2.5 to 3 and we've got this 4 to 5. We've got those jumped together, and if you measure those out, you'll see about 7.5 microfarads. So we're going to show you what it looks like starting up correctly, and then we'll drop it down to about 60%, and then we'll run it on just this guy, which will be at about 30%, and then finally we'll leave it open so we can show you what it looks like with a totally failed capacitor. Put a couple of pieces of wood on top to sort of simulate what it would be like if you had a normal amount of restrictive airflow. There's no situation where you just have a wide open blower. That wouldn't be normal. We've got this thing set up to simulate the effects of a full strength capacitor versus 60% versus 30%, and then just a totally dead capacitor. First thing we're going to show you is normal strength. This is 100% capacitance. Wasn't expecting that to happen. Doing this again at about 60% strength. We've got our little jumper wire off here, so now the capacitor is only hooked between common and about 4.5 or 5 microfarads. So let's see what happens at 60%. All right, so jumper wire's off again. Now I've got this wire moved over to the smallest output on this capacitor. So we're at about 30% of what the manufacturers call for this motor. Let's see what happens whenever we flip the fan switch on. One last shot here. No need to put the boards on this time. We've got this other side of the capacitor totally unhooked. And this is to simulate what would happen if you have a capacitor that's basically just wide open, not doing its job at all anymore. I don't know if you can hear that or not, but the motor is not spinning. I should be able to reach in here with my finger and spin it and get it going. this won't work forever. This is gonna overheat the motor and it's gonna stop before too long. Yeah, we did all this to illustrate basically the effects of a weak capacitor. And you know, putting the boards on top is really to just prove the point that having a weak capacitor isn't going to cause airflow problems. Eventually, once it got going, the motor did its job. It supplied enough air to blow the pieces of wood off the top, but that wasn't our point. A weak capacitor translates directly to higher amp draw. And once you've exceeded the limits of the motor for the amount of amps it's intended to flow, you're going to overheat it, inevitably. And that is going to bring the motor to a stop. You know, eventually you just have a capacitor one way or another that gets weak enough that it fails. Well, then you'll get the results that we showed you in the last test, where the motor just doesn't get going at all. It'll just sit there and buzz and, you know, maybe make a horrible sound. In this case, we're just running the fan, so there's no worries of anything freezing up or anything overheating. But if you've got a furnace with a fan motor that doesn't want to start, you can definitely overheat the system until the limit switches open up and the gas valve shuts off. Or in the case where this is in the middle of the summertime, you know, it's 100 degrees outside and your capacitor is weak and you're running the system. Essentially what will happen inside, if this motor is not running, is the coil will freeze up. And if you don't have any kind of flood protection or anything to that effect, it likely will flood the inside of your house. Pretty common problem.
We've learned a lot today.
The basics of what a capacitor does to get a system started.
Get a motor started, for that matter.
Be it a fan motor or a compressor motor. Which is basically that they help to get motors going. They don't magically solve airflow issues. You replace one. Fan, once it gets going, it's going to move air. It's going to draw more amps than it would otherwise. And if the capacitor is weak enough, the motor will draw enough amps, it could potentially overheat given enough time. And if the capacitor is totally dead, which is what most people experience, the motor just won't start at all, or the compressor just won't start at all.
We hope you enjoyed this episode. We intend to do a full series on HVAC repair and questions. If you have any suggestions of videos we should do next, leave a comment down below and like and subscribe. That helps us a lot. And support Tappers here.